everyone. Today we'll be learning linear equations. So now let's start. Introduction to linear equations. So what are linear equations? Linear equations are just fundamental mathematical expressions that describe the relationship between variables in a linear manner. So whenever we say linear equations, with the word linear, you must have already got it that the highest degree of this equation would be 1. So when we talk about a linear equation in one variable, the basic form that we talk about is ax plus b is equal to 0, where x is the variable and a and b are constants. Okay, so now we won't be talking about linear equations in one variable in this chapter. What we'll be talking about is linear equation in two variables, which is written in the form of ax plus by plus c is equal to 0, where a, b, c are constants and x and y are variables. Okay, now moving on. Now, how do we solve linear equations? So basically, there are two ways to solve a linear equation. First way is the graphical method, and the second method is the algebraic method. The algebraic method we will be learning in part 2 in the next video. In this, we'll talk about the graphical method. So we have already learned in polynomials chapter that the linear equation has a straight line graph. So a linear equation graph would be of this or any sort of these. Okay, so the solution, when we take two linear equations, so both of them would have a straight line graph. For example, let's take this linear equation 1 and this graph of linear equation 2. Okay, so this says that wherever they intersect this point, these coordinates x comma y would be the solution of these two linear equations. Okay, so I've given you a basic understanding of how do we solve in a graphical method. Let's dive in depth and take an example to see how this goes. So here we have an example. We have one linear equation, x plus 3y is equal to 6, and the other is 2x minus 3y is equal to 12. So first what we will do is we'll find out points to plot on the graph. This is very simple. So first what we do is, for the first equation, we take x as 0, then y would be 2, and when we put x is equal to 6, then y comes out to be 0. Now for the second linear equation, when we put x is equal to 0, we have y as minus 4, and when we put x is equal to 3, then we have y as minus 2. So now let's plot all four of these points on a graph. So this is what it comes out to be. This purple line is of the linear equation x plus 3y is equal to 6, and this black line is of the linear equation 2x minus 3y is equal to 12. And see, they intersect at a point which has the x coordinate as 6 and the y coordinate as 0. So x is equal to 6 and y is equal to 0 is the solution of these two linear equations in two variables. Okay, so now moving on. Now a question might pop in your head. Okay, so in this example, the lines intersected. But what if the lines don't intersect? So this is a very valid question that you have in your mind. So now moving on, this is the first example. This is the first case, I would say, where lines intersect. So we have an example here, x minus 2y is equal to 0, 3x plus 4y minus 20 is equal to 0. And these two lines intersect on the graph at the point x is equal to 4 and y is equal to 2. So it is written that the lines intersect at a single point, which we can see here. In this case, the pair of equations has a unique solution. The unique solution is x is equal to 4 and y is equal to 2. This is a unique solution for these two linear equations and is called a consistent pair of equations. Okay, so when two linear equations in two variables intersect, they have a unique solution and are called consistent pair of equations. Okay, now let's look at case 2. Okay, so now here we have two examples, 2x plus 3y minus 9 is equal to 0, 4x plus 6y minus 18 is equal to 0. So when we see here, both the equations have this exact same line on the graph. That means both these lines are coincident. That means they lie on top of each other. Okay, so if we read the explanation here, the lines are coincident. Correct, that both of them lie on each other. In this case, the pair of equations have infinitely many solutions. Now, what we talked about is when two lines intersect, right? That is the solution. But here, if you see, they are on top of each other. That means they are intersecting at an infinite number of points. So that is why they have infinitely many solutions and is called dependent or consistent pair of linear equations. Okay, so the previous example was also of consistent pair of linear equations. This is also consistent pair of linear equations. There's just one added thing where it is also called dependent pair of linear equations. Now, let's look at case 3. This would be our case 3. We have two examples, x plus 2y minus 4 is equal to 0 and 2x plus 4y minus 12 is equal to 0. So if we look at these lines, both of linear equation, the lines are parallel. That means they do not intersect at any point. So now, if they do not intersect at any point, that means we have zero solution. That means we don't have any solution in this. So see, if we read the explanation, the lines are parallel. Yes, we can see that. In this case, the equations have no solution and are called inconsistent pair of equations. They have no solution because they do not intersect at any point. That is why they have zero solutions. Okay, so till now we have seen three cases. In the first case, the lines intersected. The second case, they were coincident. And in the third case, they are parallel. Now, if we see, I've made a table of all the three examples that we took. If we see the first pair of lines, x minus 2y is equal to 0 and 3x plus 4y minus 20 is equal to 0. They were intersecting lines. We saw that in the graph. Now, if you look at the coefficients here, say a1 and a2. What is a1? a1 is the coefficient multiplied with x and a2 is this one, 3. So 1 upon 3, right? If we look at b1 upon b2, then we get minus 2 upon 4 is equal to minus 1 upon 2, right? And if we see c1 upon c2, which is 0 upon minus 20. So there's no pattern here. So let's move on. Let's see the second pair where the lines were coincident, right? If we look at a1 upon a2, it comes out to be 1 upon 2. If you look at b1 upon b2, it also comes out to be 1 upon 2. And in c1 upon c2 is also 1 upon 2, right? So the ratios of the coefficients of both the equations, or rather you can say constants, is equal, right? So now if we look at the third example, which is x plus 2y minus 4 is equal to 0 and 2x plus 4y minus 12 is equal to 0, we get 1 upon 2. Then b1 upon b2, the b coefficients, that means which is multiplied by y, is also 1 upon 2. But these two are equal. In the second one where there were coincident lines, these all three of them were equal. And in this c1 upon c2 is not equal, right? So they are parallel lines. They are parallel lines with no solution. In the first part, none of them were equal. So we can see, we can generalize this concept here. So which I will present in the next slide. So this is a thing to remember. If we have two linear equations in two variables of this sort, a1x plus b1y plus c1 is equal to 0 and a2x plus b2y plus c2 is equal to 0, where a1, b1, c1 and a2, b2, c2 are constants. Okay, so the ratio of constants when a1 upon a2 is not equal to b1 upon b2, then they are intersecting lines, right? And they will have exactly one solution. Now, if the ratio of coefficients is a1 upon a2 is equal to b1 upon b2 is equal to c1 upon c2, like we saw in this example where they were all 1 by 2, 1 by 2 and 1 by 2. They are coincident lines and they have infinitely many solutions because the lines will lie on each other and they will interact at infinite points. Now for the third example, if we see when a1 upon a2 is equal to b1 upon b2 but is not equal to c1 upon c2, then we get parallel lines and then there is no solution. That means we have zero solutions, right? So this table is very important. Kindly memorize this table. Moving on, we have a questions. Whatever we have learned so far, try doing these questions. These are pretty easy.